cardiac cycle. You know, sometimes people look at this and depending on the book you read or the website you're hanging out on, it starts right off the bat with these big lofty words. But in class we started differently. And we said, let's just take a second to talk about what makes sense. Right? So let's do that here. What makes sense as far as the heart is concerned? Recall, the goal of the heart is to pump blood in a specific direction. You're trying to gather it into a chamber and then push it out of that chamber in a given direction. So to accomplish this means, well, the chambers have to collect blood and then eject or move blood at specific times. And then we're going to have to coordinate valves. But let's just focus on what chambers are up to first. So let's begin with an atria. What makes sense? If an atria is relaxing, that means it's just hanging out. It's not squeezing. It's not doing anything. It's just kind of open. So if it's relaxing and it's open, do you expect it to fill with blood or squish blood out? Well, hopefully, what makes sense is that you would expect that atria to fill with blood. And that's what we're going to see. When an atria is relaxed, blood can enter. I'm going to manipulate that in a little bit. Now, what makes sense? When an atria contracts, that means it's squeezing. So what makes sense to you? Is it going to continue to fill with blood if it's squeezing? Or is it going to push blood out? Well, what should make sense is that if an atria is contracting or squeezing, it's going to push on the blood and blood's going to move. Well, let's take a look at the ventricle. And again, what makes sense? If a ventricle is relaxed, it's just hanging out. It's not squeezing at all. And it's open. So do you expect it to fill with blood or push blood out? It should fill with blood, right? If it's just sitting there open, blood should be able to come on in. If a ventricle contracts, now it's squeezing on blood. And what makes sense is we would expect it to push the blood out. So the cardiac cycle is basically going back and forth between these four events. You're going to see the atria relax, in which case blood enters it. And then you'll see the atria contract, in which case the last little bit of blood is pushed out. You'll see ventricles relaxing, in which case they're filling up with blood. And then when they become full, basically, they begin to contract, which pushes blood out. This series of four is the foundation of the cardiac cycle. It's the background. We can add levels of detail on as we go, but if you understand first and you look at it from a perspective of what makes sense, everything else follows. So let me introduce you to some of the anatomy words. When we say contraction, textbooks are going to say systole, and quite honestly, on an exam, I will be saying systole. So if I say atrial systole, I mean atrial contraction, in which case we're ejecting blood or pushing blood out. If I say ventricular systole, we really mean ventricular contraction, and in which case the ventricle is pushing blood out. When you see the word diastole, that's relaxation. So atrial diastole means atria is relaxed, its blood is entering. Ventricular diastole means ventricles relaxed, blood is entering. Now, this is the EKG and we talked about it, but remember, we're going to deal with diastole and systole. What triggers diastole and systole are electrical events. So diastole and systole are mechanical events, but they are controlled by electrical events. In class, we said this is called the P wave. The P wave tells us that the atria is depolarizing, in which case it will contract shortly after. So this segment, this P to R segment, that's during that event, that's when the atria would actually be contracting or in systole. The QRS interval, or the QRS segment here, the QRS interval is when the ventricle depolarizes. Underneath it, the atria is repolarizing. And so if it's depolarizing at the end of S, it's the ST segment here where we would expect it to contract. Okay? So do realize the EKG is measuring electrical events, but mechanical events are going to follow. Because it is a cycle, you could start anywhere on the cycle. But again, you should be seeing some of the words we've been talking about, okay? When an atria repolarizes, it's relaxed, blood is entering. When an atria depolarizes, it contracts, it ejects blood. And so you can see the ventricles up to the same thing. So here we haven't really added much on yet. The only thing I added on was that it repolarizes, then it relaxes. Or it depolarizes and then it contracts. But the concept's still the same. If an atria relaxes, blood enters. If an atria contracts, blood leaves. If a ventricle relaxes, blood enters. If a ventricle contracts, blood leaves. So let's just look at atria. When we are in atrial diastole, remember the atria is relaxed, which means it's open. Pressure of blood inside that atria would be very, very low because the atria is not squeezing on anything. So blood is entering. Now here's why you see AV valve closed. When an atria is in diastole and it's relaxed and blood's entering, the vast majority of that blood goes straight into the atria, past the appropriate AV valve, and straight into the ventricle. Atria are very low pressure systems. They're only going to contract at the end and squeeze out the remaining 20% of the blood. So what's the key here? In atrial diastole, pressure within the chamber is low. Blood is entering the chamber, going through the valve into the ventricle. And about 80% of that blood will do that. The last remaining little bit of blood actually enters the chamber and then is forced out when the atria contracts. So it's the one thing that's the exception to the rule there. In fact, if it confuses you, just ignore the AV valve for now. All right. When an atria is contracting, okay, that's an atrial systole. When the atria begins to contract, pressure builds within the atrium. The AV valve is open at this time, and then blood gets ejected through the valve into the ventricle. But remember, with the atria, as you go between its two cycles, its diastole and its systole, you're really only moving the last remaining amount of blood. Most of the blood's just going straight to the ventricle. So most of the activity then pertains to what the ventricles are up to. So before I change the side, what makes sense to you? If an atria is relaxed, do you think a ventricle should also be relaxed? If that were the case, then when the atria contracts, that means the ventricle is contracting at the same time. That would be a problem. That would mean blood is not going to move through the heart. Remember, we want blood to go atria, ventricle, out. Atria, ventricle, out. So what's happening during the cardiac cycle is while the atria is relaxed, a ventricle is contracting. While the atria is contracting, the ventricle will relax. So we're going back and forth between these four things. So let's go take a look at the ventricles and put it all together again. All right. When we're in ventricle diastole, the ventricle is relaxed. When the ventricle is relaxed, at the same time, the atria is squeezing. So during ventricular diastole, pressure within the ventricle is low. And that drop in pressure when this ventricle relaxes is what causes the AV valve to open. And remember, at the same time, our atria is trying to squeeze up there. So blood's going through that open valve into our ventricle, and our ventricle begins to fill. When pressure is low inside the ventricle, while that opened the AV valve, it keeps the semilunar valve closed. So as our ventricle is relaxed, pressure is very low. The AV valve opens, the semilunar valve is closed. And as it continues to get fully relaxed, more and more blood enters. So by the time you're in mid to late diastole of the ventricle is nearly full of blood. Well, now it's time to squeeze. So the ventricle begins ventricular systole, or it begins to contract. When it first starts to contract, it's squeezing, so the pressure of the blood begins to rise, and some of the blood moves back a little bit. That rise in pressure causes the AV valve to close. And as long as the AV valve is functioning properly, as the ventricle continues to squeeze and the pressure continues to rise, no blood's going back to the atria. All right, so let's from the beginning for this guy. So the ventricle filled in diastole, and now it begins to go into systole. It begins to contract. Pressure begins to rise. The AV valve closes. We continue to squeeze. Pressure continues to rise until it gets high enough to blow the semilunar valve open. Once the semilunar valve is open, all that pressure is pushing on that blood. And now the blood has somewhere to go because that semilunar valve is open. So the blood goes past the semilunar valve into the pulmonary trunk or ascending aorta. Okay, so one more time for the ventricle. When the ventricle is in diastole, it is relaxed. Pressure is low. That low pressure opens the AV valve, but the semilunar valve is closed. Blood fills. As the ventricle goes into mid to late diastole, it's full of blood. It begins to go into systole. It begins to contract. That squeeze starts an increase in pressure. Pressure builds. The rise in pressure closes the AV valve, and then for a period of time we continue to squeeze. Pressure continues to rise until we get enough pressure to open the semilunar valve. At that point, blood has somewhere to go. It is ejected. So take a second, get some scratch paper, write out the events of atrial diastole, and then atrial systole, and then write out the events of ventricular diastole and ventricular systole, and hang out with them. Remember, in a nutshell, a chamber's relaxed, pressure is low, it fills with blood. A chamber contracts, pressure rises, blood is ejected. The ventricles kind of control the opening and closing of the valves. So the phases, ventricular systole. Remember, that's when the ventricles are contracting. That takes place when the atria are relaxing. And remember, this increase in pressure, this rise in pressure, causes the AV valves to close first. The ventricle continues to squeeze until it generates enough pressure to open the semilunar valve. Well, let's look at what happened in between. There is a period of time when we generated enough pressure to close our AV valves, but we haven't generated enough pressure yet to open the semilunar valve. In that period of time when the ventricle's continuing to squeeze and trying to get enough pressure to blow the semilunar open, that period of time is called isovolumetric contraction, because during that period of time both the valves happen to be closed, which means the volume of blood does not change. So isovolumetric contraction happens during ventricular systole because the initial rise in pressure from the beginning of the squeeze closes the AV, but isn't enough yet to open semilunar. We have to continue to squeeze to get the pressure high enough to open the second valve. So the period of time between when the AV closes to where the semilunar opens, that's isovolumetric contraction. There's no change in the amount of blood. The pressure's rising, but the amount of blood itself is staying constant. So there you go, isovolumetric contraction. That's in early systole because both valves are closed. In early diastole, we also actually have an isovolumetric relaxation. That's that time when the ventricle relaxes, the pressure drops, there's a little backflow in the artery leaving it that closes the semilunar valve, but we haven't relaxed enough yet to get the AV valve open. So during diastole, we also have a period of time where semilunar's closed and AV's closed. There's also something called a dicrotic notch, which is a brief rise in pressure in the aorta when that left ventricle contracts. Remember that left ventricle's got that huge myocardium? So its pressure is so big that when it contracts, blood under great pressure goes into the aorta. When the left ventricle relaxes, there's a big change in the pressure and it drops a little bit. That's called the dicrotic notch. I can show that to you on a graph. So here's the dicrotic notch. It's the drop in pressure when the ventricle relaxes, but we'll learn later when we study blood vessels that the aorta is designed to manage that and to get that pressure immediately back up again. So we see an initial drop, it goes right back up. All right. You should take a second and hang out with this graph because it superimposes the ECG with the heart sounds over the pressure. Remember, here's atrial systole or atrial contraction. Okay, and so you should just be able to reason through what's going on with pressure. And to remind you, chamber is in diastole, chamber is relaxed, pressure should drop. Chamber goes into systole, chamber begins to squeeze, pressure should rise. So that's the end of the cardiac cycle for this brief review. So one more time. Chamber goes into diastole, it is relaxed, pressure drops. Chamber goes into systole, it begins to contract, pressure rises. When you get the hang of that, and you can do that in your sleep, I want you to add the next layer on. The next layer is what's happening to the blood. Is blood filling or blood ejecting? Once you can do that in your sleep, add the third layer on. The third layer is what's happening to the valves. When the ventricle is relaxing, semilunar opens first, then AV opens. Ventricle entirely relaxes, so mid to late diastole fills with blood. Ventricle begins to squeeze. Early systole closes AV valve, but semilunar is still closed. So there's a period of time when it's still squeezing, but the amount of blood stays constant. In mid to late ventricular systole, we've generated enough pressure. We open the semilunar valve in late systole, blood is ejected. So first level, chamber is relaxed, pressure drops, chamber contracts, pressure rises. Second level, chamber is relaxed, pressure drops, blood enters. Chamber contracts, pressure rises, blood leaves. Third level, ventricle relaxes, semilunar closes first, chamber continues to relax, AV valve opens second. Ventricle begins to contract, AV valve closes first, semilunar valve opens second. And then when you do that in your sleep, you've got the cardiac cycle.